I don't need to be on camera. This is such an exciting day. We recruited Casey to join our very first cohort of the master's degree in humanitarian engineering and science, which, as you'll see, combines coursework in STS and then a disciplinary track. So her disciplinary track was environmental engineering. We were so pleased that Casey agreed to work with us on our NSF PIRE project, Responsible Mining, Resilient Communities. She has this amazing background from her undergrad. She majored in both biological, agricultural engineering and was a superstar, and Spanish, and was kind of just the perfect person we imagined to do this kind of work. And I've been so impressed by the extent of her reading and really the amazing fieldwork that she did in a very short time period. And she's going to be sharing how that was possible. So in terms of logistics, I am also logged on. So if there are technical difficulties, you can text me in the chat. And otherwise, Casey's planning on talking for about half an hour. We'll have questions from the public, and then we'll have the committee discussion. So welcome and good luck.
Yeah, thank you, Jessica. Thank you, everybody, so much for being here. It's exciting to finally share what I've been doing for the last couple of years with you all. So I'm going to start sharing my screen. Can everybody see this okay? It's good? Okay.
It's okay. It's okay.
Awesome. So let's get into it. So today I'll be talking about my research on theorizing the social and socio-technical community-based engineering by incorporating a rapid assessment procedure in educational and field-based studies on Colombian artisanal small-scale gold mining. So first I'll start off with an introduction, my first case study, my second case study, and then some overall conclusions, future work, acknowledgements, and references. So the overarching research objective of my work was to help engineers and technically minded audiences rethink the social dimensions of socio-technical problems, all in the context of Colombian artisanal small-scale gold mining, which I'll explain more in a minute. And so this comes about, the tenets of humanitarian engineering of my program come about as a result of decades of failures in technically narrow humanitarian engineering interventions in which engineers fail to consider social, political, economic, cultural circumstances that led to unsustainable projects. And so now we recognize that all systems are socio-technical, that you can't separate out the social dimensions from the technical ones. And in order to do socio-technical analysis, one of the tools we use is called contextual listening, which is a form of listening in which all the technical specifications like cost, weight, etc. acquire meaning only when the full context of the people making those requirements is understood. And another part of HE is local knowledge, the valuing of local knowledge, which essentially is asserting that the residents of a place, the locals who are affected by an engineering system, are always going to know more about the holistic context than outside experts. So even if this knowledge isn't in a form that we're typically taught to value, we still should elicit it, incorporate it, and use it to guide our engineering interventions. So one socio-technical system that's particularly complex is artisanal small-scale gold mining, or ASGM. And over 81 countries have ASGM. It's a very common rural livelihood that in Colombia accounts for up to 5% of the population, depending on ASGM or ASM, as a livelihood, and somewhere between 200,000 and 500,000 people practice it. But the exact numbers are unclear because it's largely an informal livelihood due to significant political barriers in becoming formalized. So that means that they typically don't have environmental permits or mining titles, but ASGM encompasses everything from small-scale, single-family units, panning for gold in the rivers using pre-Hispanic techniques, to larger, more industrialized operations employing dozens of people using heavy machinery. And it's very controversial, largely due to the environmental impact of ASGM. Here's some photos of Colombia, Antioquia, where you can see the significant deforestation, land upheaval, loss of rivers and streams, and as well as mercury poisoning or mercury contamination is a big issue because despite it being outlawed in 2018 in Colombia, its use often persist, and there's still historic presence of mercury in tailings, leading to significant levels of contamination in the water and air. And in addition, ASGM is often connected to the financing of armed groups, which leads to further criminalization of minors. But all of that said, again, it's a very important rural livelihood for poverty alleviation in places where there aren't many other options to make a sustainable income. So given complex systems like this, we recognize it's important to do socio-technical analysis, but then how can we actually do that? That's a question that I've had since I started my master's program. And the straightforward answer is that we can use tools from social science, tools that have been specifically designed to understand the nuances of social systems in a way that technical engineering-based approaches are not equipped to do. Specifically in my thesis, we drew upon anthropology, which in short is the scientific study of humans in society that primarily relies on a technique called ethnography. And if you're not familiar with it, it's a technique that allows for detailed insight into the concepts and premises that underlie what people do, but that they're often unaware of. And it's primarily based on extended time immersed in the field with a specific community, conducting interviews, observations, and iteratively generating data through the lenses of ethnographic theory. So a lot goes into it that's invisible to the untrained eye. However, one of the issues with ethnography is that it takes a long time. And so ethnographers themselves have addressed this issue by developing a method called the Rapid Assessment Procedure, or RAP, which has been studied since the 1970s, primarily in the field of public health, in which it's basically a shortened ethnography that's used in very time-sensitive interventions such as pandemic or disease control. And it shortens ethnography by relying on a multidisciplinary, multi-member research team that includes members of the target community and professionals from different disciplines, in which everybody is simultaneously collecting data using different methods and triangulating their findings, which essentially means corroborating them with multiple methods and researchers. And they're doing so in an iterative way in which the data influences the next questions that you ask. And in addition, RAP has a relatively narrow scope compared to traditional ethnography that's purely inductive. And all of this allows for rapid completion of the data collection within a few days to a few weeks, usually. However, I identified other challenges to integrating anthropology with engineering, such as the type of data and the type of analysis that's typically done. So engineering and natural science usually relies upon quantitative data and analysis where everything is put into numbers so you can apply statistical analysis and verify trends. Whereas qualitative data doesn't usually use statistics and relies more on narrative or descriptions of phenomenon. So quantitative data can kind of tell you what's happening, whereas qualitative data is useful in telling you why that's happening. And there are also different research approaches, principally inductive versus deductive reasoning. Deductive reasoning being akin to the traditional scientific method, in which you start off with some questions, make observations, and then inductive is sort of the reverse of that, where you start off with the observations and from the data arise the questions. And it's a circular process in which you're constantly reiterating your questions and direction of research, whereas deductive is usually a bit more linear. And also, there are differing philosophical foundations between anthropology and engineering that often as engineers we don't even recognize. For instance, engineering and natural sciences are usually based on positivism, which asserts that there are fundamental natural truths about systems that can be uncovered using the scientific method and then applied across different temporal, different circumstances, basically, different situations. Whereas interpretivism asserts that every bit of knowledge comes from a specific situated point of view or context. So what holds true in one place doesn't necessarily hold true in another place. And this is especially pertinent for social systems. And finally, there are just differing timelines, as I mentioned, between ethnographic and engineering projects. And engineers are not trained to think like ethnographers. So this is where my work comes in. I did 2 different case studies that I'll outline now. The first case study had to do with engineering education, in which I worked with students who were participating in another course in which they designed ASGM tools with communities. And I presented this study to an audience of systems engineers and engineering educators with the main objectives to present a humanitarian or HE-based RAP as a framework for conducting front-end stakeholder needs analysis, and then explore the outcomes of teaching and applying this with students working on ASGM projects. And I wanted to understand what the student perceptions of RAP were, what their demonstrated learning outcomes were, and what qualitative stakeholder needs they were able to identify in a practice mini-RAP. And then the second case study was the main focus of the thesis. And this was when I actually went to the field to a Colombian ASGM community and implemented RAP myself. So the audience for this study, we framed it as a socio-hydrological study that also applies to ASGM researchers. And the objectives were to build upon a wider discussion in socio-hydrology about how to better understand social hydrological systems, and then to ground this argument with our field-based case study by using RAP to characterize human water systems in our field site. So we wanted to identify the barriers and opportunities for implementing tools like RAP in socio-hydrology, and then practically understand what we could learn by applying RAP about coupled human water systems in our study site, and ultimately how these qualitative findings could complement previous quantitative work done on this project. So the first case study is titled Rapid Assessment Procedure as a Tool for Front-End Stakeholder Needs Analysis in Engineering Projects, which I submitted to the Open Journal of Systems Engineering. And for some background, as I already mentioned, engineering students are not usually trained to analyze technical systems to the same degree as social ones. And these shortcomings in their social training translate to engineering practice, which has led to practicing systems engineers to call for formalized activities for front-end stakeholder needs analysis, which is essentially another way to say understanding socio-technical systems. And so the workshop that I designed consisted of an initial lecture in which I taught these undergraduate engineering students working on ASGM. I taught them about HE and social science frameworks, gave an overview of ethnography and RAP, and then gave them specific instructions on different techniques for interviewing, observation, and archival research, which are 3 ethnographic methods. And then they had an hour to conduct their own mini RAP in the place where we were, which was Gunnison, Colorado. So they broke up into groups of 3 with an interviewer, an observer, and an archival researcher, and went out into the field. They designed research questions, research plans beforehand, and then went out, talked to people, took notes, made observations, then came back to the classroom and triangulated their findings amongst their groups and then amongst the entire classroom. And we also brainstormed what this would mean as engineers working in this context with these specific stakeholders. And finally, I gave them a post-workshop writing prompt to assess their retention of the concepts in the lecture, as well as ask them to generate questions to ask ASGM community members in their upcoming virtual community visit. So I analyzed the data by making video, audio recordings, observations from graduate student observers, notes from the students themselves, and then written prompts as well, by using inductive grounded analysis and thematic analysis. And the main themes that I identified were the student perceptions of RAP, the demonstrated learning outcomes, and the student engagement. And then beyond the scope of my own study, the students went on to conduct this virtual ASGM community visit, ask the questions that they wrote in their writing prompts, collect qualitative data that then informed their designs and prototypes for different ASGM tools. So we found very positive, ubiquitously positive perceptions by the students of the RAP tool as a concrete way to do social and technical analysis and understand the wider culture surrounding their projects. The student engagement was very high, with one graduate observer noticing that the students were energized, excited, and really interested in the activity. And the students demonstrated an ability to recognize the different techniques I presented them, and then as well as when it is best to use them. For example, using interviewing and observation in virtual settings, asking open-ended and closed questions. And then in their writing prompts, they generated all different types of descriptive and socio-technical questions for ASGM stakeholders. Here's an example of a technical versus a social question that a student came up with. And in Gunnison, they were able to generate really rich data on stakeholders in a relatively short period of time. So in conclusion, this workshop had very high student engagement, positive learning outcomes, and the students identified social circumstances that otherwise would not have been asked about in a purely technical study. That said, the students had pre-existing interest in this type of socio-technical analysis because they opted into this broader summer course. So that probably enhanced the learning outcomes. But nevertheless, RAP shows promise to be a good tool for stakeholder analysis in different educational and practice settings. Okay, so the next case study was on theorizing the social and socio-hydrology, incorporating ethnographic methods like RAP to characterize coupled human water systems in rural Colombia, which I plan to submit to the Water Resources Research Journal. And for some background, the field of socio-hydrology is a branch of hydrology, which is the scientific study of water. And about 10 years ago, they came to the reckoning that their understandings of hydrological systems were incomplete without understanding the ways that they affect and are affected by people. So socio-hydrologists have since sought to quantify and model human behavior to improve their predictive capabilities with hydrological models. However, this has led to critiques of an asymmetrical integration of social and hydrological theory because most people are essentially studying the social systems as if they were hydrological systems. And social scientists and socio-hydrologists alike have recognized that there are significant limits to quantifying qualitative, nuanced social data, leading to some socio-hydrologists to do pluralistic studies in which the social aspects are analyzed using social science theory and hydrological parts are analyzed using conventional hydrological modeling. And these pieces serve as discrete parts of a larger, more complete understanding of the entire socio-hydrological system that aren't mutually exclusive in any way. However, there's a lack of case studies in the literature with rigorous social analysis where they actually say what their methods are and give the social side as much attention as the hydrological side. So this is kind of where my research was situated. So we sought to understand what RAP could tell us about the coupled human water systems in Andes, Antioquia, Colombia. And Andes is a municipality in about 3 hours southwest of Medellin that has an ASGM population. As you can see here in the photo on the right, this is an ASGM processing center with ball mills used to grind up the ore. And in the background, you see a coffee farm. So this is a very fitting photo of Andes because it has both sectors, agricultural and ASGM. And much like you can't understand social without the technical, in Andes, you can't understand ASGM's impacts on the environment without understanding how it's intertwined with agriculture and agriculture's impacts on the environment as well. So we conducted RAP in the field with a research team consisting of 2 local women, seen here in the photo in the top right, 2 local women who both participate in the mining and agricultural sectors, 2 students from our Colombian university partner who are studying mining engineering, and 2 students from the Colorado School of Mines, myself and Cecilia, who are studying humanitarian engineering with an environmental focus. And with this team, especially with the help of our 2 local contacts, we were able to engage over 65 stakeholders in Andes, conduct 32 semi-structured interviews. Semi-structured meaning that we had some pre-formulated questions, but we left the format open so that stakeholders could talk about what they were most interested in or answer questions that we hadn't even thought to ask. We conducted 4 focus groups, which were also semi-structured in nature, but having a larger audience lets you analyze different social dynamics like power dynamics and controversial or prevailing opinions, things like that. And we combined our interviews and focus groups with site visits to farms and mining centers where we got to see firsthand how people were using and affected by hydrological resources. So in summary, through this ethnographic process, we found that residents were perceiving hydrological risks in 3 main areas, including climate change, water quality, and landslides and erosion. And in turn, these risks were threatening their livelihoods and lives, for instance, by lowering the coffee yields, lowering the general agricultural yields, because 2021, they didn't have a dry season hardly at all, which led to significant losses in coffee production despite all-time highs in prices of coffee. Increased contamination from both the mining and agricultural sectors, with mining being perceived as a longer term but more severe threat, while agriculture was a more ubiquitous but perceived as a less severe threat contamination-wise. And then dangerous conditions due to landslides, principally. For example, this happened less than 2 weeks ago, where 3 children were killed in a school in Andes due to a mudslide. And this is because of increased deforestation and erosion due to the expansion of both mining and agriculture. So the residents were adapting to protect their livelihoods and lives, principally by changing their practices or diversifying their livelihoods by gaining more than one stream of income. So here's a photo of somebody who built a rain cover for their farm. Some people went into trout farming in addition to coffee farming and mining. Another common one was for coffee farmers to supplement their off-season income by going into ASGM. But in turn, we found that these adaptations often exacerbated the original hydrological risks that people felt by increasing contamination, increasing deforestation, and destabilization. So all of this resulted in what we identified as a livelihood diversification hydrological degradation paradox, as seen here in this figure on the right. However, this is very difficult to interrupt given prevailing political and economic circumstances, such as the cycle of debt that many farmers are trapped in due to agrochemical loans, limited options for viable livelihoods in the area, the significant hurdles to becoming formalized as miners that reduces incentives to improve environmental practices, widespread corruption and lack of trust of the government and other rural institutions that are meant to promote rural development, leading to the feelings of abandonment by the residents and the idea that they had to get by whatever means possible, resulting in economic and environmental trade-offs, and trade-offs for short-term income and security versus long-term environmental and human health risks, unfortunately. And so our data can complement previous quantitative studies done on the Pyre project, such as the hydrological study done by Kristen Roberts, in which she correlated global environmental variables such as El Nino with precipitation and stream flow in Andes. So here on the graph, she demonstrated the correlation between lower sea surface temperature in orange and higher stream flow in Andes and vice versa. So this tool can tell us, it can give us a season ahead warning about hydrological conditions that residents can expect, whether that's extreme flooding or droughts. However, this doesn't tell us how people are actually going to feel these changes and adapt to these changes, and then what the subsequent impacts on the hydrological systems are going to be. And Rosalie O'Brien did a survey in 2019 of 100 residents of Andes in the farming and mining sectors to identify their greatest perceived environmental risks, And she also found that mercury use in ASGM and pesticide application from coffee farming were the 2 main concerns. However, what this survey cannot tell us is why these activities have persisted despite recognition of their negative consequences on the environment. So in conclusion, we were able to identify through this ethnographic approach that the mitigation and livelihood decisions in response to hydrological risks have actually, in many cases, exacerbated these hydrological risks. And this tool provided a more complete understanding of the coupled human water system and why this paradox is happening, to help us rethink technical hydrological approaches and when and how these can actually be most beneficial. So in conclusion for the overall thesis, for the first case study, we sought to present the RAP tool as a framework for front-end stakeholder needs analysis, which we did in the article by making theoretical arguments and synthesizing literature from AG and anthropology. And we explored the outcomes of teaching and applying RAP with students. through the RAP workshop. And we answered the questions about what the student perceptions were. They were overwhelmingly positive, useful perceptions of the tool. They demonstrated good learning outcomes by being able to recall and apply when to use each method, generate socio-technical questions, and triangulate interesting qualitative data in a short period of time, such as data on identity, economic factors, environmental mindsets in Gibson. And so in the second case study, we sought to contribute to the wider debate in sociohydrology about the best way to understand social systems by presenting epistemological arguments, critiquing previous sociohydrological studies, and building upon authors that advocate for pluralistic studies. And then we grounded our theoretical arguments with a field-based case study in Andes, in which we characterized the complex human water systems qualitatively. And to identify the barriers and opportunities that existed for integrating these types of tools in sociohydrology. Again, these are epistemological, methodological barriers. However, there's recognition within the field that these are problems. And so there is an impulse to explore new methods and approaches. And the application of RAP in our study site revealed important threats to hydrological sustainability and the risk-informed decision-making mechanisms underlying these cycles, as well as critical points of intervention that I talk about in my thesis. And so these qualitative findings complemented previous quantitative approaches by illuminating the effects and causes of the trends that were seen in quantitative studies, like from Roberts and O'Brien. So in summary, there are diverse technical disciplines that recognize the importance of doing socio-technical analysis, but simply lack the tools and training to do so. And so by relying on transdisciplinary tools and theories, specifically those from social sciences like anthropology that are designed to do this type of work, those can be very helpful. However, it requires education on these diverse methodologies, as well as the underlying epistemological frameworks that dictate how we approach problems in the first place. And we demonstrated that engineers could learn and apply tools like an HE-based RAP effectively to characterize complex socio-technical systems, such as ASGM. And future research questions would be on different theoretical logistical barriers to applying ethnographic and similar methods in other natural science and engineering contexts. And it'd be really interesting to see what can be revealed through more case studies of different durations with different stakeholders and target communities. And how would training engineers and engineering students in social science fields affect future collaborations with actual social scientists? Recognizing that engineers are engineers, not expert social scientists. So the collaboration is important, but oftentimes we're speaking different languages. And does this livelihood diversification hydrological degradation paradox we identified hold true in other ASGM communities and other farming communities and other rural communities? And why or why not? And what factors may influence this? And I hope to answer this question myself through a research dissemination trip, but how can we actually collaborate with community members to identify ways to interrupt this unsustainable paradox? And future research in Andes could also investigate the other factors influencing livelihood decisions beyond hydrological risks, such as the geological makeup of the area that influences cycles of gold mining, such as different labor practices, cycles of weather, harvesting seasons, these things that also influence when people do which activities. And I would like to acknowledge all the institutions involved in the PIRE project and the NSF for funding this work. And thank you to my thesis committee, Jessica Smith, my advisor, Kathleen Smith, my co-advisor, Juan Lucena and Oscar Jaime Restrepo Baena, my two committee members, for your constant guidance and answering all my questions. And my research team in Andes and all the participants who helped me with this study, and the friends and family who supported me along the way. So here's some references. And yeah, that's it. Thank you.
That was wonderful. So now is our time for questions from the general audience, and we'll hold the committee questions until our time with Casey.
Yeah, if you have a question on Zoom, you can put it in the chat or unmute yourself and ask it.
I think Simon has a question.
Oh, I like it. Okay. Do you think social scientists can also, oh, thanks, Libby. Do you think social scientists can also be trained to better communicate with engineers in a similar fashion? What would that look like? That's a really good question, Simon. I never thought about, well, I haven't thought deeply about that before, but yeah, I mean, similar to the way that we're just training engineers in basic social science tenets, I think the same could be done with social scientists by teaching them about different engineering mindsets, like from the work of Donna Riley, or teaching about engineering problem solving approaches. There's a lot of literature on the way that engineers are trained to think. So I'm sure by referencing that kind of literature and the STS field in general, that's what the science and technology studies really focuses on, is understanding the ways that engineers and scientists' minds work and how they make decisions and their behaviors. So yeah, I would recommend looking into STS. And yeah, maybe my advisors have some more specific resources on that.
We're living proof.
Yeah, they're living proof. Yeah.
I have a question that builds on that one, but that's okay.
Yeah.
So again, amazing job. You've synthesized just an incredible amount of literature into two really coherent, really clear projects, and like walked us through them. You walked us through an amazing amount of work, and it is really in really impressive fashion. So great work. My question is very similar in how we prioritize engineering and the technical as we think about socio-technical systems. So in your work, I hear an inherent critique of socio-hydrology, but I don't hear an inherent critique of water studies. And so I'm wondering, like, why is that? Is it who you're trying to enroll? Is it the nature of HES as a program? Like, why is it that we care about the technical as much as the social?
Right. And by water studies,
Yeah.
water studies, you mean traditional, like
Anthropologists, sociologists,
okay.
Geographers thinking about how water and humans are connected.
Yeah.
You know what I'm saying? Like,
Yeah.
why that isn't a part of your story. It's a tough question. I've given you a tough question, but I'm wondering what seeing the blame of socio-hydrology as the gap gives you, or the motivation for doing that, opposed to the other way.
Right. Was everyone online able to hear that question? I don't know how much the mic picks up in here. Okay, great. Yeah, so that's a really good point. I think I focused on socio-hydrology specifically because it is self-proclaimed as this transdisciplinary area that wants to integrate the two fields. Like, it's not markedly on one side or the other, as water studies seems to be, or really hardcore hydrology or environmental engineering. So because it exists in this transdisciplinary area, I was just kind of poking at it a little bit to say, well, are you doing an equal job of integrating the two parts? And of course, equal is hard to measure because they're very different fields that have different methods of analysis, methods of research collection, and all of that. But just giving as much attention to the social, that was really not done. In the conference I just went to in Puerto Rico, the Frontiers in Hydrology conference, another person who presented with me wrote a review article about socio-hydrological studies, finding that, I don't remember the exact numbers right now, but a very, very small portion of socio-hydrology studies actually said what their social methods were. They would go into great detail about their hydrological models, but when it came to the social, it was almost no description of the methods of analysis, the methods of data collection, what theories were actually used to ground the generation of data. So it's just the field of socio-hydrology has a long way to go specifically in order to reach its own ideals of integrating social and hydrological theory for better predictions. If that answers your question. Whoever wants to go first.
Okay, I'll go first. Well, I'm sorry if I misunderstood what you said, but I understood that there is a hydrological paradox. My question will be more like I'm Colombian, so I have seen that in these little farms, people just want multiple incomes. So they're not thinking about the hydrological risk, they're just thinking about feeding their families and having like different incomes. So how do you say that they start like having all these other ideas because of the hydrological risk? Yeah, my question is more like, how do you know it is a cause of the hydrological risk and not just because they need more income and they are just trying to survive and have like other income sources besides mining or agriculture?
Yeah, no, definitely. I mean, the hydrological risk is a factor influencing these livelihood decisions. However, it's not by any means the only factor, because like you said, usually people are motivated by economic need and the need to frankly just put food on the table. So they'll do whatever is necessary to make that happen. However, they're feeling these hydrological risks in a practical way, like when climate change and changes in weather pattern affect their coffee yield, for instance, or lead to increased contamination in their trout farms and death fish kill and things like that, then they're forced to kind of do something else on the side to compensate for the problems presented by the hydrological issues, if that makes sense. Did you have?
Yeah, I don't know if there is like a quantitative way of correlating that or like some meaning, because that has happened for many years. There is always sometimes that whether it's dry, I come from a family of farmers, so I know that has happened for many years.
Yeah.
So it's not something new that the climate change. It's just that weather sometimes also changes. So like my question will be like, more how do you relate that to the hydrological factor rather to what it naturally happens in nature?
Yeah, so we found, at least in our qualitative study, a lot of people were telling us, like, yes, weather's always been an issue, but that it's increased. People estimated within the last 15 or so years, at least in Andes, it's become a lot more volatile. Whereas, I mean, they may have been romanticizing previous generations, but they would say like, oh, when my grandparents were farmers, they knew exactly what week to plant, exactly what week the harvest was going to be, exactly when to do this, when to do that. And they say, it was more predictable back then. So surely if there are the quantitative measures from the past, you could compare and see if climate change has and how much it has affected weather in recent years. So basically this qualitative can also serve as a foundation for where to go next. So you could do a lot more quantitative studies based on that and decide what we need to start measuring, what we need to start monitoring to address these issues. If that answers your question. Thank you.
Yeah, so I mean, first of all, just fantastic work. Like the amount of stuff you crammed in here is amazing. Like focus groups, a ton of interviews, practice with students, just this is great. So my question is kind of like, if you were going to take some of those findings you got in focus groups about power structures and dynamics, is there a way that you would incorporate, if you were imagining taking this forward, sort of the political or policy realm, where you might be able to connect that to the social and hydrological? Do you have a sense for where you might go with that? And this is purely speculative. If there's no answer, there's no answer.
Yeah.
But yeah, I just love to kind of hear where you think this could go.
Yeah, I think that's a really important point, because ultimately policy is what's going to be able to guide more systemic changes. I didn't focus too much on policy in my degree program. That wasn't a major focus of my own. But I do know that a lot of the hurdles were political. They weren't necessarily because we lacked the model that demonstrates this is happening. They weren't because we lacked the scientific evidence that this is happening. I mean, if you look at even just climate change broadly, like we already know scientifically that it's happening, but what we need is political change to do something about it. So the same definitely holds true in Colombia. I'm by no means an expert on the Colombian political system because it's very complicated. I mean, the political system here as well. But I know that there's a lot of work done around formalization. That was a huge focus of the broader research, the broader PIRE project itself is about helping people become more formalized, helping them organize into grassroots associations that can allow for political advocacy power and things like that. And that kind of work is already sort of being done in the farming sector. It's a little bit, I saw more organization within the farming sector because they are less stigmatized and not operating so much on the informal margins of the law. But so they had a lot of groups that were advocating, working with the National Coffee Federation, trying to do training, trying to do things like that. So hopefully that addressed some of your question.
Yeah, for sure. It was just fascinating seeing like agrarian debt being an issue here, and with like Moroccan apple farmers is another area to know about. So it's like it's very universal in how you connect that with policy. So it's really interesting. So thank you.
Yeah.
So our last question will be from Alejo.
Okay, Casey, congratulations for your work. As everybody has mentioned, it's amazing. I just have like, if you could like summarize your theory contributions to the social, that is as the title of your dissertation. What would you like propose, like 2 or 3 theorizing conclusions or contributions to all this field knowledge?
That's a good question. I would say one of the main ones is the integration of the humanitarian tenets with the RAP methodology, because RAP, again, it's been very widely applied in public health, and it's been applied a little bit in engineering, but in the cases I saw, it was always applied as like a last step. Like, we have this product, we want to see how the community is going to accept it, so we'll bring it there, we'll do a RAP. Whereas the humanitarian engineering tenets advocate for integrating local knowledge, integrating community-based perspectives and priorities from step 1 and iteratively throughout the whole project. So using RAP as a tool to facilitate that kind of social analysis, yeah, that connects those 2 realms of thought.
Amazing. Well, let's class. We'll ask people online. You can leave your congrats in the chat, and then if you could please excuse yourselves. Thank you all for coming. For those of you who are in person, it's wonderful to have an audience.
Yeah, thank you.
Sorry,